like I mentioned before, this presentation I created a couple years ago and ran. And my original intention was to educate people on things that I was already kind of including in my advanced courses. I've updated it to put more in, and the intention that I had when I was putting these slides together was to really try and give you a bunch of information about things to consider when you're deciding where to paddle, when to paddle. Some of it is you'll need for your preparedness, but also things to maybe when you're choosing places to paddle, give you some ideas of what you might expect based on environmental conditions, amount of wind, land formations, all that kind of stuff. So I'm going to go through the presentation, and it's really focused on wind, waves, and tides. With the wind, I started at a very, very basic level. So if it feels like a bit of an eye rolling, like everyone knows this, hopefully we get past that quickly. So wind, well, I'm hoping to introduce ideas that let you understand what we need to know regarding wind, where to find forecasts, and how to apply the information that we're seeing. For waves, understanding how wind speed, duration, and distance affects waves. So there's all sorts of things that create waves, and there's all different types of waves. But today I'm going to talk specifically about wind waves, so waves that are created by the wind. Tides, introduction to tides, what creates tides a little bit, and then somewhat on how they affect us. And then overall preparedness we'll do that at the end, and that's a section I pulled from my instructor manual of what I've created to help new instructors get used to what they need to check before they take their students out. So, tiny bit about me. Really old picture. I wish I looked that young still. It's about 4 years old. That is my dog there, and that is him barking in the background. So yeah, I started in tech a long time ago. Did that for about 14, 15 years. And then this is when I was in Ontario. Ended up quitting that. Ran a business teaching paddleboarding, running all sorts of different events for about 6 years. So most of my paddling was on flatwater reservoirs and the Great Lakes, which, as Wendy can tell you, are very big lakes, and they get very choppy and very messy quite easily. So lots of fun. Since moving to Vancouver, I've been here almost 6 years. Since being here, basic advanced touring lessons, instructor trainer. Paddle Canada is what I do. The other things that I do when I'm not paddling, I teach a lot of yoga. As we get older, we need our bodies to keep moving and reacting in ways that we want to have them react so that we can keep enjoying the sports we choose to partake in. I do hike guiding and I teach hike guide instructors, or I teach new guides, and Red Cross instructor. All the things that kind of get you out there. And Red Cross is relatively new for me, but it was becoming quite apparent that Red Cross is something that, or first aid is something that, is pretty important to have if we're going to be out a long time, out on the water a lot, and away from 911 ambulance that's more than an hour away. So it all just seemed to kind of fit together for me. Okay, so when we get into winds, very, very basic. This is what I was talking about. This is the compass. And the reason I'm throwing this in is I've come across enough people that where it just kind of gets a little bit confusing between knowing how to understand how to label the wind and differentiate it from, when we're going in our own direction. So if we were on the water leaving Jericho and heading towards West Van, we would be going north. So we would be heading north. If the wind was coming from that direction, the wind would actually be coming out of the south. So there's differences in how we label the direction that we're traveling with the compass as opposed to the direction the wind is coming. So I just wanted to make sure that was quite clear. So the example is if we are here in the middle of our compass and we're standing here on the Jericho Sailing Center, we label thinking of ourselves at the center of the compass. So the direction we would be heading is if we were heading straight across to West Bay here, we would be heading north. If we were going downtown, we would be heading east if we were actually traveling. The wind, on the other hand, as if we were standing here in the Jericho Sailing Center and the wind was coming from and facing the water, the wind could be coming from our left, which means it's coming from the west, heading east. We always label that as a westerly, or that would have a speed and have a W on it. So wind is always labeled from the direction that it's coming from. The other example I have here is if the wind was coming from behind us and blowing from land to the water, it would be coming from the south or a southerly. So just keeping in mind when we're looking at our forecasts that the direction or the north, south, east, west that's on there is going to be the direction it's coming from. And also really quick, I'm just going to hop back a second. Mostly what you're going to see when we're looking at directions is north, south, east, west. We might see northeast, we might see southeast, we might see southwest and northwest. So those are just the, the 90 degrees in between. You can fine tune it even more, but for the most part, we don't do that for weather because the wind's changing enough. We don't need that level of accuracy. All right. So when we're looking at wind, I always start, especially my basic lessons, by just getting folks to get used to using apps that they have on their phone. So one of the really traditional ones is the Weather Network. So I pulled this here. And I always tell folks that what we need to know is always going to be on the hourly report. So here at 3 p.m., the wind will be 11 kilometers an hour. So if we look at 3, we have 11 kilometers an hour out of the west and the gust at 15. If we look at hourly, we can see the trends of the weather as it goes along. So it goes 11, 12, 8, and then starts dropping. But we can also see that the direction is shifting so that at 8 o'clock, we're coming out of the southwest. So at the very beginning, when I am introducing people to the idea of really checking the weather for the entire duration of time that you're out there, as opposed to just looking at what it's doing right now, I encourage them to look at the Weather Network on hourly. Once people start becoming more familiar, like many of us are now, and some of us are still learning, then we're going to go to an app like Windy, a Wind Finder, but they have so much on them that they can be overwhelming. So I usually get folks to start here. Also worth noting, the wind is expected to drop here in this example, like I mentioned, at 8 p.m. So that starts painting a picture of what we're going to see for the day. And it's important when we're heading out to know what the weather is expected to be doing while we're out and for quite a while afterwards. If you're going out for a full day or an overnighter, you want to know what that weather is expected to be doing at least a day after you're supposed to return, just in case something happens, so that you know what you might get caught in. Other things to consider. So in the Weather Network, we use kilometers per hour because that's our typical unit of measuring that we're used to. Weather Network, we're usually on land, so it is always using kilometers per hour unless we've changed a setting. When we start looking at nautical units or nautical or marine forecasts, they're always, unless we change a setting somewhere, going to be in knots. So we have to make sure that when we are looking at our weather reports and wind reports, we're understanding the unit that it's being presented in. So kilometers per hour is easy to understand or judge by many folks because we're used to it when we're driving our car. We know distances, we know speeds because that's the units that we're measuring them in. So we can relate easily to, if we drive a car 50 kilometers an hour, if the wind came up at 50 kilometers an hour, we got kind of an idea. Of course, with 50 kilometers an hour would be an insane wind to be paddling in. Marine specific websites, we're going to see knots, and the short form for knots mostly is KT. You might see a KN once in a while, but mostly, especially with aviation and marine, it's KT. So we need to be able to convert them. If we're used to kilometers an hour and we're looking at whether that's in knots, we have to be able to convert that into something that we're familiar with. So here I just went to Google and said convert 11 knots per hour, or kilometers per hour, to knots, and it gives me a measure that you've probably seen before, or a window that you might have seen before if you're converting anything using Google. 11 kilometers an hour is 5.9 knots. Really though, for the detail that we don't need to use this. We don't need to multiply by 1.8 times 2 for your knots is what we want to consider. So if we have knots of 6 knots per hour, we just multiply it by 2 to give ourselves approximately 12 kilometers an hour. So 6 knots is going to be roughly 12. So you can start to see if you're looking at a forecast that says 6 knots and you're thinking that it's kilometers or kilometers per hour, we're going to have a very big discrepancy in what we're actually going to find when we get out there. So it's really important to understand the units that we're working in and have a quick understanding of how we can convert back and forth. Sources of weather. So Weather Network, other good sources. I paddle a lot in Jericho because I like a lot of swell and I like choppy, windy water sometimes. So my go-to is always the Jericho Sailing Center website. If you go to the weather setting, it's going to tell you in knots what the current speed is, what the wind has been for the last 10 minutes, so you get a bit of a history. And then it'll also tell you with graphs, longer trends that shows you what the overall trend has been. Has the wind dropping? Is it increasing? So this is a huge resource because it is not a forecast, it's what's happening right now. And they also have webcams, so you can get an idea of what's the water look like. So that is a great go-to for before you go to the beach, or even pulling it up on your phone before you get close to the sailing center to know is it going to be a good option to go paddling there. Other website that you want to have a look at or become familiar with, and I'm going to show you these at the end of the session, is the Marine Forecast. So Environment Canada Marine Forecast. I would say that I would use this more so if I'm going to be out in larger bodies of water. House Sound, 100%. If you are out, Howard was probably looking at it when you were up in Nanaimo, because you're going to be in much more exposed areas, and anything that has a shipping lane associated with it is going to have information here. So I'm going to spin back to this later on towards the end of the session to talk more about this, because you can get a lot of valuable information. Some of it's forecast and some of it is also real-time data. So hugely helpful. So when we start looking at, so we're getting away from where to get our forecast, and we'll apply the forecasts and how to use them at the end of the session when we look at preparedness. But when we start kind of moving in my presentation here away from where to get the data, we want to start looking at maybe some of the behaviors that we can expect when we're out on the water. So I've got some diagrams here on Google Maps. Google Maps is your best go-to, or any sort of aerial map of an area if you're going somewhere new before you show up, to give you an idea of what does the water look like, what's the land look like around it, maybe get an idea of are you in a recessed area, if it's a river, or False Creek where you have a lot of buildings on the sides, creating a tunnel or a wind tunnel. It's going to be the best bet for giving you an idea of what you might expect. So here in this first picture, you can see we have the wind coming out of the west. Oops, I'm trying to draw a circle around the west. And so we know that if the wind is coming out of the west, it's blowing this way. And say it was 15 kilometers an hour, we know that by the time the wind comes down here towards Stanley Park, English Bay, we are looking at 15 kilometers an hour. We'll talk more about what we might expect from that. But the wind's not going to stop there. So the wind always takes the path of least resistance. So we're going to be getting wind blowing us maybe around to False Creek, and we might have the wind starting to take different paths through over towards the bridge. What it's not going to do so much is go straight through Stanley Park, because there's all sorts of trees there and there's barriers. So the wind is always going to try and filter itself around. So in the next diagram over, I wanted to talk a little bit about narrowing of wind. So the wind is going to take the path of least resistance, and the path of least resistance can often be dictated by what's on the sides of the water. So if it's just a beach and it's really flat, that wind's just going to continue to blow. But in the example of False Creek, we have a narrowing of the channel here. We have bridges that are narrowing the channel. And then that wind just continues to follow its way down the creek, because there's really no easy way for it to get out. It's easier for that wind to blow the length. And Venturi effect, I don't know, just because probably going back to grade 10, maybe physics, maybe grade 11 physics. What that tells us is that anytime a fluid, so whether that's wind or water, passes through a narrowing channel, pressure drops, which doesn't really matter to us, but speed increases. So anytime there's a narrowing, if I have 15 kilometers an hour coming in through Burrard Inlet, by the time that starts finding its way into False Creek, it's probably substantially higher. So we're going to see a lot more wind in through there. We're going to feel a lot more apparent wind or feel more wind in through False Creek because of this effect. So again, if I just step back at what I was mentioning, by looking at the maps in advance, when we're going to new places, we can look at the weather of what we're expecting, wind, we can look at land formations a little bit and see if we can get an idea of what are some of the challenges that we might expect to see when we're on the water, considering these types of things. So hopefully that kind of makes sense. So just to talk a little bit more about Venturi effect, I thought this was a really cool diagram here. Sorry, I have two different screens here, so if I'm looking to the right a lot, it's so I can draw on the screen. This first diagram here was actually, I found it's in relation to wind turbines, and they were talking about how windmills should go away, because if we take wind in through a big opening and then narrow it down using this Venturi effect, we get a much higher speed wind right here. So, it's gone from 10 miles an hour to 40 miles an hour based on that narrowing. So that kind of tells you, it's hard to think of scale with that, but we can get a substantial change when we see that in narrowing areas around us. What that diagram was just talking about was we should be using different technology like this to actually harness the wind and get more effect out of it. Over here on the right-hand side, we're talking about high gradient winds. So this is, if you've ever been to Alouette Lake, Golden Ears, it's very high on both sides. It gets extremely windy there because that wind just howls down the middle. It's forced into that channel. It doesn't go off to the sides because the sides are too high with mountain and trees. So we get that strong wind that blows down the middle. We see the same thing in Indian Arm. As soon as the heat of the day comes up, mountains heat up, hot air rises, and that wind just whistles down Indian Arm, and you get a huge inflow that is going to be really hard to paddle against. So those are all things that we might be able to look in advance at, and maybe best guess as to maybe I come across this when I'm looking, because we know what those contours are. So how does this affect us? Wind speeds will increase as we move into narrower passages, and current, we'll talk about this later, will also increase. So current, because it's based on tides. Waters are fluid. If we pass it through narrow passages, we are going to have a lot more current, which will definitely affect our paddling. All right, so we've talked about winds, how to label the wind, some resources on where to find what the speeds are. Some basic, some ideas of land formations and how that might affect us while we're out there that we might be able to look and find out about advance. So next, I just want to talk a tiny bit about winds that are obvious, other than speed, have the potential to have negative effects on us when we're paddling, especially if we're new paddlers. So we have a difference between onshore wind and offshore wind. So in this diagram, the very first label is N. So if I'm standing here on the side, wind coming out of the north, which it doesn't really do, it's probably more from northwest, coming straight into shore, is an onshore wind. So an onshore wind literally means it's blowing from the water to us. So it's coming from the north, a northerly wind blowing towards us. So that is the safer of the winds, because that is the wind that will blow us back to shore if we stop paddling. So an onshore wind is always a little safer because we're going to end up back on land, at least in this area. Next scenario, wind blowing out of the south. So this is an offshore wind. So it's starting where I am standing on shore, or where somebody is standing on shore, and blowing out. So that's an offshore wind. So the tendency of the offshore wind is when we're paddling and not paying attention or stopping for a drink, we're slowly drifting further and further out to water. So we have to be much more aware and much more alert as to where am I on the water, and where am I tending to be able to drift? Where am I tending to drift towards? Because the other thing is, if we are simply paddling, I would say in an offshore wind, you always want to paddle horizontal to shore so that you aren't blowing out. You never want to go straight out. And that's where people really get into trouble, especially when we're new. They paddle with the wind and they think they're rock stars because it's at their back. It doesn't feel super strong. And you get way out until you turn around and go to come back in. And then you realize that now I could be in trouble because this wind is super strong. I've been out paddling all day. I'm tired. I didn't bring enough to eat. And now I have to paddle a long ways back into the wind. So we have to be very conscious of that. The reason we want to know that, when I mentioned earlier that, when we're looking at that weather forecast for the entire day, we really want to be aware of wind speed changes and direction changes, because an offshore can easily turn into an onshore and vice versa, depending on the time of day when we're out. So all of this is information we want to start being aware of when we're planning. Where are we going to paddle? How long are we going to be out there? Am I going to be paddling into the wind both directions? Or is there a way I can, get the wind at my back going out and coming in? So all of these things start playing in. The last one, southeast. This is kind of a combination between the two. So southeast is going to be going in this direction by this arrow. That's kind of a combination of it is basically an offshore, maybe even a little more dangerous again, because it's not going to just take us to the center of Burrard Inlet. It's going to take us all the way out to sea. So have to be very, very careful of those ones. So if that was blowing at, 15 kilometers an hour, that's a lot of work to paddle back against if we've gone out quite a ways. So we just want to be really aware of that. I've been teaching lessons. I've been teaching SUP for 10 years. And what I've noticed is brand new paddlers, the size of the paddleboard is the size of the world, because all you're thinking of is stand, manage where I am, and our situational awareness doesn't start actually happening until we've been out a number of times and are more comfortable. So until we have situational awareness, we have to be very, very cautious and force ourselves to check where we are to make sure that we're staying safe if we know we're in these offshore kind of conditions. All right. So good to know. Winds often drop towards sunset. These are just facts. When the land heats up during the day, especially in summer, we get wind currents that turn into onshore winds because they come from the water. They come across the cool water. As soon as that wind hits the air, currents take that air straight up currents take the air straight up, creating winds that just circle over top of the water. So we end up with an onshore wind quite often. That can turn around as soon as the sun drops and the earth starts cooling. I learned a fact from windsurfers last year that when they want to know how much wind to expect at Jericho, the sailing center area, they look at the weather in hope. So when we're talking about, this idea of land heats and air rises, it's not on the beach. It's way inland that this is happening. So these big winds and these big formations are huge. So if there is a 5-degree difference between and like an increase, if it's 5 degrees warmer in Hope than it is in Vancouver, they know they're going to get substantially more wind than even the forecast is calling for, simply because of that extra effect. Sun cools, land cools. That's why we get winds dropping towards sunset, which is typical unless there's a storm front coming in. So that gives us an idea. It's going to be super windy. I'm going to wait and catch a sunset tour. And winds are often at their peak midday because that's when everything's the hottest. So things to be aware of. You're going to get the most wind midday. Mornings, evenings are going to be your calmer, typically. All right. So applying what we've learned. Weather forecast. So if we have these scenarios, so we have 20 degrees, water temp is 10 degrees, so it's chilly. Wind is 20 kilometers an hour southwest. So that's a stiff wind. Probably more wind than a very beginner would want to be out in. 15 kilometers an hour is kind of the max for brand new. Wind gust. So I didn't mention gust, but gust is that, when the wind blows up and then dies down. That steady wind, is our wind speed. The gust is what it blows up to and then drops from. So that gives us the highest amount of wind we might expect. Cloud cover, 80%. So I always look at cloud cover because I want to know, is it going to be hot or am I going to be cold? So with this forecast, oops, I don't know what I just did. Okay, a steady, fairly strong, what we can expect, a steady, fairly strong wind with strong gusts coming out of the southwest. The wind out of the southwest will be more of an offshore, so it's going to tend to blow us away from shore, but at least it's blowing us towards Stanley Park and not Victoria. Offshore intending to blow us towards northeast. Winds of this speed will create chop. So this is when we start looking at high speeds. What else are we going to expect on the water? Because 20 kilometers an hour is going to start creating wind waves. It's going to start with chop, and the longer that blows, the messier the water is going to be. So paddle plan, I would suggest paddling west to start. So if I was starting here, I would paddle west. So you want to do the work to go into the wind, paddling to shore, not going so far out. So we want to paddle horizontal, not letting ourselves blow out. And then ideally we're able to catch some of that wind at our, or not have to fight it all the way back in, but we still have to do a little bit of work to come in because it's coming off of our back right quarter. So I put the question down here. I didn't fill it in. You can answer this in your mind, but I'll give you my opinion. What would you wear? So we always dress for the water temperature. 10 degrees is cold. If you end up in the water, you're going to be cold. 80% cloud cover. There's not a lot of sun to warm us up. So if we get wet, because it's going to be wavy, and we get out of the water and we're wearing a bathing suit and a rash guard, we're going to be cold. So I would suggest some sort of exposure gear, shorty, 20 degrees. We don't want to have too much on, or at least something that we can layer and change while we're on the board. So it might not be a full-on wetsuit. Maybe it's a shorty. Maybe it's your favorite neoprene top or leggings that you can adjust while you're on the board, because you always want to be prepared for, I can't warm up. And if we get cold, of course, the risk there is borderline hypothermia if we're out too long and we can't get warm. Before that, we end up losing strength and all sorts of bad things start happening. So by looking at that information, we kind of get an idea of what our paddle plan is.